All right, let's take a look at solving simple interest problems. Our interest equals principal times rate times time. In this first example, we're given P, R, and T. So we just have to enter it into our formula. I equals PRT, where P is 1,000, R is a rate of 8%. 8% in decimal form is 0.08 times 3, where T is in years. This is equal to 1,000 times 0.24, or 240. So the interest for number 1 is $240. For the second one, we're being asked to find P. We're given the interest being 196. And this time we don't know what P is, but our rate is 0.07 and our years are 2. So first we can multiply our rate times our years like we did in the last problem, getting 0.14. And now to isolate P, we'll divide both sides by 0.14. So that P equals 196 divided by 0.14. And this answer will be in dollars, if you want to put your dollar sign there. 196 divided by 0.14 is $1,400. Let's look at a couple of problems using the future value formula for simple interest, where the future value A equals P times the quantity 1 plus R times T. In the first problem, we are just looking for A, the future amount, which is P times 1 plus R times T, where P is 2,500, and then we have 1 plus, and inside parentheses, 0.08 for 8% times 3. Now what we have is 2,500 times 1.24, where 0.08 times 3 is 0.24, and then we add that to 1. 2,500 times 1.24 equals a dollar amount of 3,100. So in the future, if we deposit 2,500 into an account with an 8% annual interest rate for 3 years, we'll have $3,100 at the end. In the next problem, we want to have $2,400 at the end of 4 years in an account that earns 5%. So what amount should we deposit into this account? So using our formula, we'll put 2,400 for A, set that equal to P times quantity 1 plus the rate, which is 0.05 times 4. And now, just like this other side, this first problem, when we did have P, we'll clean up the quantity 1 plus 0.05 times 4. .05 times 4 is 0.20. So this is 1.2. We don't need the 0. And now if we divide both sides by 1.2, we'll isolate P. So P will be 2,400 divided by 1.2, which is 2,000. So if we deposit 2,000 into the second account after 4 years, we'll have $2,400 in the account. Now let's look at a couple of compound interest future amount problems. Again, in the first problem, we'll just use the straight formula and find the future amount. I guess that's true for the second problem here as well. Because this time, something that can change for us is the amount of compounding that's happening. Okay, so using our first formula, our first problem, we're compounding quarterly. When we compound quarterly, that's 4 times per year, so that our problem becomes A equals P times 1 plus R over M raised to the power MT. You can use the exponent n, or you can use what n represents. If we use the numbers we were given, $1,000 for our principal times the quantity 1 plus the rate 0.06 for 6% divided by M, which is 4, raised to the power M times T, which is 8. Now, what we do is we clean up the inside of the parentheses. So 0.06 divided by 4 plus 1 is 1,000 times 1.015 raised to the power 8. So now we take the 1.015 and we raise that to the power 8 and multiply by 1,000, which yields a dollar amount of $1,126.49, rounding to the nearest cent. So after 2 years, in this account that's compounding quarterly, we'll earn $126.49 because that's how much has been added to our account. Now, if we're compounding monthly, like in the second problem, then we're compounding 12 times a year. Using our formula, A equals P, which is 10,000, times the quantity, 1 plus R over M. R again is 0.06 for 6%, but M is 12. The exponent is 12 times 5, which is 60. So this money stays in the account for 60 compounding periods. 0.06 divided by 12 plus 1 gives me 10,000 times 1.005 raised to the power of 60. We raise the 1.005 to the 61st, and then multiply that result by 10,000, which gives me a dollar amount of $13,488.50, rounding to the nearest cent. So after 5 years in this account, we earned $3,488.50. Not bad if you put some money away, right? In this problem, we'll find P. So if we know we want to have $30,000 in the bank in 15 years, planning for our retirement maybe, and we found this account that pays 4% and compounds quarterly, then how much should we put in the account? Using the compound interest formula, which is A equals P times the quantity, 1 plus R over M raised to the power M times T. We don't know what P is this time. We know we want $30,000 in the end. So we leave P alone, and R is 4%, so 0.04. Compounded quarterly is to say 12 times per year, raised to the power 12 times 15, which is 180 compounding periods. So what we need to do is 0.04 divided by 12 plus 1 raised to the power 180. And I'll say rounded if you want. I'll stick everything in here that the calculator is giving me. Now, if I divide both sides by that quantity, then we will isolate P. Then we'll know how much money we need to deposit. I'm getting that we need to deposit $16,480 and 79 cents in order to have $30,000 in the bank. That's pretty decent. We nearly double our money if we do that. I like that. I like doubling our money and having $30,000 for retirement.